Hello, welcome to CEN 4801. In this session, we will continue our discussion about system development life cycle, and we will address some of the approaches used in the system development life cycle itself. Some of the very well-known approaches to implement a successful system development life cycle are the waterfall system development life cycle, the prototyping, rapid application development, end user development, computer aided software engineering, object-oriented development, and some of them like tools that can be used together or can be joined together to produce the proper system needed for the organization. Again, those are methods of implementing the system development lifecycle and not implementing the system itself. So until now, we did not develop the system. We're just looking at the how to manage the life cycle of developing the system. In the next few slides, we will address each approach separately. The waterfall model was introduced by Royce in 1970. It was initially used for software development, but now it's used for products and system development too. The waterfall model usually consists of 5 to 7 series of steps or phases for system engineering development. It starts with collecting requirements. The second step will be to analyze those requirements or the collected data. Third will be mapping requirements to design specifications and creating the design. The fourth step will be the implementation phase. In case of a software system, we start writing the code at this stage. The fifth step is the testing phase to make sure that the system is working as intended. The sixth step is deploying the developed system into the real life situation, and the seventh step is maintaining that system to continue going. In the system's requirements, problems and opportunities are identified and documented in light of the goals of the business. System analysis will study existing systems and work processes to identify strengths, weaknesses, and opportunities for improvement. Systems design will answer that question on how well, or any questions on how well the system do what it must do to obtain the problem solution. And then with systems implementation, the creation or acquisition of various system components detailed in the system's design, assembling them, and placing the new or modified system into operation. Once the development completed, testing phase starts with or that phase will start, and each unit or component will make sure that it's developed or is working as expected. Once testing is completed, and make sure that there is no bug or defect or any kind of issues, then system is deployed to operation. The system's maintenance and review ensures the system operates as intended and modifies the system so that it continues to meet changing business needs. Waterfall model is also known as linear sequential life cycle model, since we move to next step of development or testing if the previous step is completed successfully. So it's a sequence of events or activities that's been done one after the other. When the first one is completed, the second one will start. The waterfall is very successful for small systems. Once a step is completed and the next step started, we cannot revert back to the previous step. So some of the advantages of a waterfall model, it's very good approach for small systems, as we said. It's easy to use and follow. Sequential. So we look at the sequence of event, and based on that, we complete each one of them separately. It's cost effective. It doesn't cost much to build or follow or to design or to use it for the development process. Each phase completely developed. Um, we will not move to the next phase unless we complete the stage or the phase before. Development proceeds in sequential manner, so very less chance to rework, and it's easy to manage during the development of a system. And then it has easy process of documentation. The waterfall model has the following disadvantages. And it will not be useful if the system got bigger or complicated. We said it's easy for a small one, so it's not easy for big one or complex one. If the requirements were not documented in a clear way from the beginning, the wrong design will be created, which will affect the proper implementation of the system. Because of its sequential nature, it will be very difficult to go back to the previous phase. We said that you cannot revert or you cannot go back to the previous stage. The testing starts once development completes, so more and more chances of bugs to be found, during the testing. All these issues makes this model high risk and less flexible for many complex and large systems. Another approach to implement a successful system development lifecycle is to use a prototyping model. The prototyping model is an iterative approach to systems development that consists of building an experimental system rapidly for end users to evaluate. In each iteration, the requirements will be collected, analyzed, and the design will be specified and implemented. The user will review, then the developer will move to the next iteration, and so on. You can see that, with the three iteration that's been shown here, you can see that for each iteration we have developed initial system that will be reviewed by the user, and then we move to the next iteration, and so on. So we can design as many iterations as we want, just to capture to make sure that we are going to capture the user requirements and user needs. In each iteration, the requirements will be collected, analyzed, as we said, and the design will be based on the analyzed requirements. By interacting with system users, developers, it can get better, or we can get better idea of the system requirements. Once operational, the prototype will be further refined until it conforms precisely to user requirements. Prototyping will be a good approach to select when dealing with systems that have lots of uncertainty about the requirements, such as software development, information systems, enterprise resource planning systems, content management systems, and so on. Since the approach has an intense end user involvement throughout the development process, it will be more likely to produce a system that fulfills user requirements. On the other hand, rapid prototyping can skip essential steps in systems development, and if the completed prototype is working well, management may not see the need for additional improvement or documentation. And it's called the good enough system acceptance by the management. If it works, why to work on it? That's it. It's working, just release it to the users. In addition, those rushed and rapid developed systems may not be agile and flexible to any expansions or additions. It's just something that I did fast, released it. The user is using it, so maybe it will not be flexible to any changes, or it cannot be expanded. The spiral approach is another iterative rapid prototyping methodology where work activities are repeated. With each iteration, developers can refine a previous result or results. It's considered a risk-driven approach where it allows for an evaluation of risk before proceeding to a subsequent phase. Mostly, this model adapts to the large and complicated systems where risk is high. With this kind of approach, changing requirements can be accommodated. It allows extensive use of prototypes. Requirements can be captured more accurately, which will facilitate resources allocation. Users see the system early. Development can be divided into smaller parts, and the risky parts can be developed earlier, which helps in better risk management and cost control. But managing the spiral model is more complex, and to begin with, less defined objectives may be uncomfortable for management. End of the project or system development may not be known early, and spiral may go on indefinitely, iterations. Um, Users will continue asking for something, or customers will continue asking for functionalities, and we continue development. So it might go forever and ever, which is not good. Large number of intermediate stages requires excessive documentation. In some cases, there is a tendency to push difficult problems to the future so that the initial promise of the first increment is not met by subsequent products. If we don't have defined objectives, it might be incompatible with a formal review and audit procedure. The V process model is an approach that starts with user need on the upper left, and as you can see here in the um, slide or in the figure, um, and with user validated system on the upper right side of the figure. On the left side, decomposition and definition activities resolve system architecture, creating details of the design. The integration and verification flows upwards to the right as successively higher levels of subsystems are verified at the system level. The verification and validation advances from the component level to the validation of the operational system. During the testing process, the originating specifications and requirements documents are consulted, since we have documentation for everything, so we can go back and consult with those to ensure that components, subsystems, and the system meet user specifications. The development and progress in the V model is very organized and systematic. It will not work if the requirements are not consistent. This model works well for smaller to medium sized system but not suitable for bigger and complex systems. There are other system development approaches that uses mix of multiple methods to speed up the development process. This slide and the next few slides will provide some examples of such approaches. The rapid application development, which is called RAD, is a system or systems development approach that employs tools, techniques, and methodologies designed to speed application or system development. Rapid application development uses visual interfaces to allow people to drag symbols around the development environment, connect them to in specific ways, and create a system with little or no code requirement or required. Since the code itself is automatically generated, that delays any bugs due to typographical errors, and that everything will be minimized. There will not be error as when you write the code from scratch. Some iterative development approaches allow the system to change as it is being developed, such as the agile development, which involves frequent face-to-face meetings between systems developer and users. And we have also the extreme programming or XP, which is a software development methodology intended to improve software quality and responsiveness to changing customer requirements. Especially when you are developing a software that you keep on using the customer feedback, and customer would like more functionalities, more tools, and additional changes to the software interface or software functionalities. One of the tools used extensively by RAD or Rapid Application Development is Joint Application Development or JAD, which is a process for data collection and requirements analysis in which users, stakeholders, and system professionals work together to analyze existing systems, propose possible solutions, and define the requirements of a new or modified system. JAD utilizes group support systems (GSS) software to foster positive group interactions. End user systems development, for this we have any system development project that the primary effort is undertaken by combination of business managers and users. So the end users are the one who's involved and taking over. So end user developed system can be structured as complementary to rather than in conflict with existing and emerging information systems. Since we are involving the managers and users of the business to develop the system, that's why we have less conflict with other information system or other existing information systems. It seems that all these methodologies require lots of resources. So organization will analyze their capabilities and available resources to take the proper decision of using in-house resources to develop the required system, or to outsource it to a specialized company. And in most cases, companies will not have the resources enough to develop a system in-house, so they will outsource it. When we say outsourcing, that means an outside consulting firm or computer company that specializes in systems development that can take over some or all of the development and operations activities. So, what are the factors that will be affecting the decision of outsourcing? The first thing that most companies, most organizations look at is cost. If using internal resources will cost more, than outsourcing, then it should be outsourced. Now remember that maybe I will not have the capabilities, the skills for developing such a system. So to hire people, skillful people, and to bring people with expertise on the development process might cost a lot. In addition, I need technology that will support those people during the development stage. That means I have to buy workstations, servers, software packages, anything that will support them. All that will cost money. So cost always is the main factor of taking the decision of uh, making it in-house or outsourcing it. Also, organization can look at other capabilities such as their computing capabilities, and by selecting an outsourced company, they will be selecting state-of-the-art computing technology company that will eliminate the need to hire specialized people internally, and will be pushing the operations and maintenance cost to the outsourcing company. I don't need to worry about the operation cost of these servers or these workstations, to update them, to maintain them anymore. They have These companies have the capabilities to take over with their technology state of the art and start developing the system for us immediately. Um, Computer aided software engineering, or CASE, is a tool um, that automates many of the tasks required in system development effort and encourage adherence to the system development life cycle. With that being said, it's a tool that can be used with other methodologies. So it can be used by um, some of the methodologies mentioned before. So it adds a high degree of rigor and standardization to the entire system development process. It's used as a tool under RAD, the Rapid Application Development, to improve the speed and quality of the system development. The front end tool of case is called uppercase, while the back end tools are called lowercase. Um, it's just easier to name it like uppercase, lowercase. Depending on the scope and scale of the project, either um, one of the tools or a combination of tools may be utilized. Uppercase tools are designed for the early stages of the system development life cycle and are used for project planning, systems analysis, and general systems design. The lowercase tools are designed for the back end of the system development life cycle and are used for detailed systems design, system implementation, and system support. The most common lowercase tools are the code generators, but others include compilers and test support tools. The advantages of using case as a tool are producing systems with longer effective operational life, a system that will be closer to meeting user needs and requirements, and it has excellent documentation. A system that's closer to users' needs and with such documentation will need less support, less maintenance. In addition, it will be flexible and can adapt to any changes. The problem with using case, or let's say disadvantages, that it will increase the initial costs of building and maintaining systems. To capture users' needs, it requires more extensive and accurate definition of their needs and requirements, which makes it difficult to customize. This kind of tool requires more training of maintenance staff. It's easier to use these tools when building a system from scratch, but might be very difficult to use it with existing systems. Object-oriented systems development is a common approach to modeling systems by using the object-oriented paradigm throughout the entire development life cycles. Basically, visualizes things in a system by using models organized around objects. This approach combines the logic of systems development lifecycle with the power of object-oriented modeling and programming. The major phases of software development uses object-oriented methodology are object-oriented analysis, object-oriented design, and object-oriented implementation. Object-oriented systems development typically involves identifying potential problems and opportunities within the organization that would be appropriate for the object-oriented approach, defining the kind of system user required or requires, designing the system, programming or modifying modules, evaluation by users, and periodic review and modification. By reviewing all that, now we know the methodologies that's been used for system development, and we can choose one to develop our system and then start, collecting requirements, analyzing them, and go with the different phases based on the selected methodology. With that being said, that will be all for this session. And if you have any questions, you can email it to me, you can call me, or you can come in person, and I will be more than glad to address your concerns. Have a great day.